All right, so here are the solutions to our Unit 3 Day 6 warm-up. So just like we covered in class last time, we're solving for y. We need to get y by itself. So number one, -7 is the only term that is on the same side that y is. So we're going to do the opposite to get rid of it or undo it. So we're going to add 7 to both sides. Our 7's will cancel here. I get y by itself. And then remember, 5x plus 7, we are not able to actually do that. Those are not like terms, so we just need to write it in slope-intercept form. Our term with our x goes first, right? That is our slope. And then the term that's by itself, the y-intercept goes second. So y equals 5x plus 7. So our slope there would be 5 over 1 if you were needing to answer that, and your y-intercept would be 7. Okay? All right, number 2, -5y equals 10x minus 5. So in this case, we just need to get rid of that -5. But based on how that's formatted, -5 and y are being multiplied, so we need to divide by -5. And remember, when we multiply or divide, we must do it to every single term. So our -5's cancel. 10x divided by -5 is -2x. -5 divided by -5 is +1. All right, number 3. Okay, this is going to be a 2-step, right? We're still needing to get y by itself. We need to get rid of the 4x and the 2, right? So we want to get rid of the term farther from our y first. Let's get rid of this 4x first. Well, it's a positive 4x, so we want to subtract 4x from both sides. Now, I don't have y by itself yet, but we're getting closer. It's just 2y. Again, this right side, we can't actually take -10 minus 4x in our calculator, right? These are not like terms, so we need to write these in slope-intercept form. So the term with our x needs to go first, which is -4x, and then our -10 second. And then finally, our last step, we're going to divide by 2. And because we're dividing, we must do it to all terms. -4x divided by 2 is -2x. -10 divided by 2 is -5. And we solve for y. Okay. Go ahead and turn your paper to the back side. Okay. For the sake of today, let's skip 1. Let's do number 2. Okay. All right. We got Tiny's dog is 12 pounds, and Marcy's dog weighs 30 pounds. Tanya's dog gains 4 pounds each week, while Marcy's dog gains 2 pounds each week. Write and solve an equation. So we know it's an equation. We know it's going to be an equal sign to determine when the dogs weigh the same. Okay? So we got Tanya's dog over here, Marcy's dog over there on that side of the equation. So let's focus on Tanya's dog. Currently, she is at 12 pounds. So that's straight number, 12 pounds. And then if I keep looking, Tanya's dog gains, so gains means we're going to add to that weight, 4 pounds each, right, means times, for each week. 4 times W, 4 times weeks. All right, now we got Marcy. Her dog currently weighs 30 pounds, okay? Marcy's dog gains, so we're adding 2 pounds each week. Each means times again, 2 each week. All right, so we have it set up. We look to combine like terms or distribute on each side, which I cannot. Each side is already simplified, so we're going to move our W's to one side and our constant numbers to the other. So I'm going to move my W's over here. Okay, so I'm going to get rid of this positive 2w by subtracting 2w. 4w minus 2w is 2w. Those cancel, and I'm just left with 30. Now I'm going to get rid of my positive 12 and get it to the opposite side. 30 minus 12 is 18. And then we're finally going to divide by 2. W equals 9. So it'd be 9 weeks for that process of the dogs, one dog gaining, one dog losing weight, for them to be the same. All right. Okay. You guys can turn bell work in, and then notes will be handed out here shortly. Okay, so our notes. Okay, this is our last lesson before we are going to take our test. Okay, so the last thing we're covering in Unit 3 is when to determine if lines are parallel or perpendicular. All right, so right here where I have parallel, it says sketch a picture of what parallel and perpendicular lines look like. So parallel, here's an example. There's a line. There's a line, right? Those lines are never going to touch. They're going to stay the same distance apart the entire time, even if they extend in opposite directions in opposite directions forever. So parallel would be an example. Perpendicular, here is an example. Okay, that is a 90-degree angle. So it's when two lines intersect and they form a 90-degree angle. Okay? All right, so what we're going to do here is we're going to look at these next three examples. We're going to just kind of determine and see if I notice any patterns here. Okay? So, problem number 1, we're going to plot both lines on the graph. So in my top equation, it says y equals 2x minus 3, right? So on this one, our slope is 2 over 1. Our y-intercept, negative 3. So we're putting our first point where y is negative 3. And then my slope tells me to rise 2, up 2, right 1. And we also can go down 2, left 1. And I'm going to put my point. Connect my points, making a line. All right, the other equation, okay, right underneath that, y equals 2x minus 1. My slope is 2x. My y-intercept is negative 1. So I'm going to put my first point down 1 on the y-axis at negative 1. And then my slope tells me to 2 over 1, right? Rise 2, run 1. And we can also go down 2, left 1. All right. So we just plotted those two lines based on the equation, okay? All right, let's look at number 2. We'll come back to kind of identify what we see in these problems here in a bit. Y equals x minus 2. So that top equation, our slope is 1 over 1, right? X is by itself. We could put a 1 in front of the x. To make 1 a fraction, we put 1 over 1. Our y-intercept is negative 2. So I'm going to go down 2, put my first point. And my slope tells me to go up 1, right 1. And we could also do the opposite, down 1, left 1. Make a line. Now let's look at our bottom equation. Y equals negative 1/2 x plus 1. So my slope is negative 1 over 2. My y-intercept is positive 1. So let's put our first point on the y-intercept, up 1. And then a negative 1 over 2 slope tells me to go down 1, right 2. And if I do the exact opposite, I go up 1, left 2. And, whoop, that's not a very good line. Roughly something like that, okay? And finally, number 3. Let's go ahead and plot both of these lines on this third graph. So we have in the top equation, y equals 3 over 4x plus 4. Our slope is 3 over 4. And our y-intercept is 4. So let's plot that y-intercept first. Go up 4. And then a slope of 3 over 4 tells me to go up 3, right 4. And then we can also, from our y-intercept, go down 3, left 4. Put a point. Or connect our lines. Connect our points with a line. And then let's look at the bottom equation. We have y equals negative 4 over 3x minus 2. So our slope is negative 4 over 3. Our y-intercept is negative 2. So we're going to put that first point on the y-axis where y is negative 2. And then a slope of negative 4 over 3 tells us to go down 4, right 3. And then we can also go up 4 from our y-intercept, left 3. Roughly something like that. Okay. So, like I said, we're going to come back to these and kind of identify what makes those lines do what they do in a sense. Okay? So, let's go ahead and fill this next part out. All right. parallel lines. So, right, an example of parallel lines would be something like that. Okay, definition, lines that never intersect. They stay the same distance apart. Okay? Now, if I have two equations, how do I know if those two lines will be parallel? It's all about what the slope is. If the slopes are the exact same, okay, you will have parallel lines. Okay, that's going to be important to know. Look at perpendicular. Definition, lines that intersect, and then they have to not just intersect, but they have to make a 90-degree angle as they intersect. So a lot of lines intersect, but they are not perpendicular unless they form a right angle. So something like that, where you have a 90-degree angle. Okay, now how do we know if two equations have lines that are perpendicular? It's if their slopes are opposite. So I put this underneath it, which means one has to be a positive and one has to be a negative. And not just that, and they have to be reciprocals, which means fractions need to be flipped. Okay, so one of the slopes need to be positive, one needs to be negative, and it needs to be flipped. Okay, so let's go back and look at these lines that we made. If you look at number one, those two lines are parallel. Right, I'm on this one right here, I just started. Those two lines are parallel. Well, what makes them parallel? Look at your slope. My top equation, my slope was 2 over 1. My bottom equation, my slope was 2 over 1. Those are the exact same. So without having to even plot it, you should know that those two lines are going to be parallel because the slopes are the same. So those are parallel lines because the slopes were the exact same. All right, look at number 2. My top slope was 1 over 1. My bottom slope was negative 1 over 2. Well, they're not the exact same slope, so they can't be parallel. So now if I look to see if they're perpendicular, well, we know for them to be perpendicular, the slopes have to be the opposite, which means one has to be positive and one has to be negative. If I look at that top equation, 1 over 1, that's positive, and the bottom one, it's negative 1 over 2. So that fits. They're opposite, but they also need to have be the reciprocal of each other. Well, if I look at 1 over 1 and negative 1 over 2, if I were to flip 1 over 1, it would just stay 1 over 1, right? It's not going to be 1 over 2. So those are neither parallel or perpendicular. They're not parallel because they're not the exact same, and they're not perpendicular because they're not opposite and reciprocal of each other. Okay? All right, now let's look at the last one, number 3. Look at that top slope. I have a 3 over 4, and my bottom slope is a negative 4 over 3. So they're not the same, so we know they're not parallel. Now when I'm checking for perpendicular, are they opposites? Is one positive, one negative? Well, this top one is a positive, this bottom was a negative, so that checks out. Now let's see if they have the reciprocal. The top one is 3 over 4. If I were to flip that, I would get 4 over 3. If I look down here, I have exactly that, 4 over 3. So they are opposites, meaning one's positive, one's negative, and they are the reciprocal of each other. So these ones are perpendicular lines. It's all based on the slope. You don't really worry about the y-intercept in determining if you have parallel, perpendicular, or neither. It's all about the slope. Again, if the slopes are the exact same, it's parallel. If the slopes are opposite, meaning one positive, one negative, and reciprocal of each other, in flipped fraction, they have to fit both of those, it's perpendicular. And if it doesn't fit either of those, you would just say neither. Okay? All right, let's look at this last part on this page. So when it asks for the slope here, so I'm right here, I just start it. When it asks for the slope, it just wants to know, is it positive, negative, 0, or undefined? So look at the equation, y equals 4x plus 7. Looking at the slope, I see a 4x, right? Whatever is in front of our x identifies our slope. So that is a positive slope. I'm just going to put a plus for positive. And what would that line kind of look like? If it's a positive line, it's going to go upwards somehow, some way. Okay? Next one, I have x equals 4. Well, this one, right, starts with an x. That automatically makes my slope undefined. And an undefined line is vertical, straight up and down. Okay, next one, y equals 8. Okay, well, there is no x after the equal sign, so the slope is 0. And a 0 slope, the line is horizontal, side to side. And last one, y equals negative 2x plus 5. I just want to know the slope, negative 2x, so it means it's a negative slope. And a line that is a negative slope is going to go downward somehow, right? Left to right, it's going downward. Okay, go ahead and turn the page. So we're going to be focusing on mostly parallel and perpendicular and just identifying, based on the two equations that I have, okay, if they will be a parallel to each other or perpendicular to each other. Okay, so each box, we're going to put the corresponding answer, okay? So underneath this box, I want the current slope of what I have, okay? This one, what would be a slope that would be parallel to it? Again, the exact same. And then this last box, it's what would a slope be in order for it to be perpendicular to the current slope? It means it needs to be opposite, positive, negative, and flipped. Okay. So remember, since I'm talking about slope, I'm only focusing on the part that has our x. Okay. So y equals 3x minus 5. Our current slope is 3 over 1. Okay. What would a parallel slope be? The exact same, 3 over 1. Now, a perpendicular slope means it needs to be the opposite. Well, our current slope is positive. That means this needs to be a negative. And the reciprocal. What's the reciprocal of 3 over 1? 1 over 3. So a perpendicular slope to 3 over 1 would be negative 1 over 3. Okay, next one. My current slope is 3 over 4. A parallel slope to that, the exact same, 3 over 4. A perpendicular slope needs to be the opposite. Well, my current slope is a positive, so this needs to be a negative. And reciprocal, flip it, 4 over 3. So if you had a slope of 3 over 4 for one line and a slope of negative 4 over 3 for another line, they would be perpendicular to each other. Okay, continuing on, our slope in this one is negative 1/3. That's the current slope. That's what I have. A parallel slope to that would be the exact same, negative 1 over 3. And a perpendicular slope to that would be the opposite sign. Well, this one's negative, so ours needs to be positive for perpendicular. So it's going to be a positive, and then I need to flip it, the reciprocal, positive 3 over 1. Okay, next one. Y equals x plus 10. Our slope is right here with this x. So if there is an x, there is a slope, right? Our slope is not 0 here. The number I could put in front of that x is 1 if I wanted. So my slope would be 1 over 1. That is my current slope. Well, a parallel slope to that would be the exact same, 1 over 1. Okay? Now, a perpendicular slope, opposite sign. Well, our current slope is a positive, so this needs to be negative, and I need to flip that fraction. It'd be 1 over 1, right? Well, since both numbers are the same, it's just, there's nothing else I can do about it, right? When I flip it, it stays 1 over 1. So a perpendicular slope to a positive 1 over 1 is negative 1 over 1. Okay, next one. Current slope, negative 4 over 1. Parallel slope to that, exact same, negative 4 over 1. Perpendicular slope, opposite sign. So this needs to be a positive since my current slope is a negative, and flip it, 1 over 4. All right, continuing on. My current slope, negative 1 over 1. A parallel slope to that stays negative 1 over 1. Perpendicular, it's got to be the opposite, so it's going to be a positive since my current slope is a negative. And if I flip it, it's 1 over 1. So positive 1 over 1. Okay? y equals 7. What is our current slope if it's just y equals a number? 0. Well, what would a parallel slope to that be? The exact same, 0. Now, this one is maybe a little tricky to think of, but if I had a 0 slope, my line would look like that. Okay, if I put a vertical line right through that, I just created a 90-degree angle. Okay, so what is that red line? What slope is that if it goes vertical, straight up and down? It is undefined. So a opposite reciprocal slope of 0 is undefined. Just remember that. Okay, and the last one, since it starts with an x, our slope is undefined. What would be a parallel slope to an undefined slope? Parallel, exact same, has to be undefined. Again, here is a parallel line. Sorry, not a parallel line. That is a vertical line, which is an undefined slope. If I put a horizontal line right through it, again, I'm creating a 90-degree angle. So that would be a perpendicular line to the red line. What is that blue line slope? 0. So for perpendicular, 0 and undefined are perpendicular. Okay? All right, last part here. Okay, all we need to do is look at the equations. Some of them we may need to solve and just identify what our lines would be. Would they be parallel, would they be perpendicular, or would they be neither? For parallel, we're gonna write that symbol. For perpendicular, we're gonna write that symbol. And if they're neither, we're gonna just write an N, okay? All right, so look at the top equation, 2x, that current slope is 2 over 1. Bottom equation, negative 1 over 2, okay? So those are opposite signs and they're flipped. So our answer is perpendicular. Number 5, top slope is 3 over 1. Bottom slope is negative 1 over 1. They are opposite signs, but if I flip 3 over 1, it's not negative 1 over 1. They're not the exact same either, so this one is neither. They're not the same, and they're not opposite and reciprocal of each other, so it's neither. All right, number 6, top slope. If it's x by itself, it's 1 over 1. Bottom slope, x by itself, it's 1 over 1. Those are the exact same, so parallel. Okay, my formatting here is a little goofy, so just hang tight with me on these next 3. All right, 7, my top slope, 3x, 3 over 1. My bottom slope down here is 1 over 3, okay? They're not the exact same, so they're not parallel, but they are the reciprocal of each other. 3 over 1 and 1 over 3 are flipped. However, they are both positive, okay? In order for it to be perpendicular, one would have to be positive and one would have to be negative. So even though they're the reciprocal, they're not opposite, so these are neither for number 7. Okay, number 8. Our top slope is negative 3 over 1. Now, be careful here. On number 8, the bottom equation, the y is not solved for. It's not by itself. So what we're going to have to do is we're going to have to solve for it. You can't tell me what the slope is until y is by itself and it's in slope-intercept form. So we need to solve for y first, and we need to subtract 3x from both sides. And then I need to put this correctly in slope-intercept form, so I would say negative 3x plus 5. Now I can look at my slope. I have negative 3x, so it's negative 3 over 1. If I look at both of those slopes, they are the exact same, so they are parallel. Okay, number 9, the top equation, it is solved for, so I can go ahead and identify my slope right away. It's 2 over 1. However, the bottom equation is not solved for. We got to get y by itself, and this one's going to be a 2-step. So we're going to want to subtract 2x first. I have 4y left. Let's put this in the correct form, negative 2x plus 6, and then we're going to divide by 4. And because I'm dividing, I must do it to every term. Okay, remember, slope here needs to stay in fraction form. So even if you divide, hit your ABC key, it's going to reduce it to negative 1 over 2x, and then if I take 6 divided by 4, I get 1.5. So let's look at this slope now. It's the negative 1 over 2x. I'm going to write it up here. Okay, so those are my 2 slopes, right here and right here. My top slope is 2 over 1. My bottom slope is negative 1 over 2. One's a positive and one's a negative. And if I flip them, it checks out. 2 over 1 and 1 over 2, they are reciprocals of each other and they're opposites, so these are perpendicular. All right, moving on to number 10. Our current slope, if y is just a number, it is 0. X equals 2, x just a number, it is undefined. And we said if it's 1, 0 and 1's undefined, those are perpendicular, because one is a horizontal line, one is a vertical line. They will form to make a 90-degree angle. Okay, moving on to number 11. My top equation, y equals -3. Well, that's just y equals a number again. My current slope is 0. Bottom equation, y equals x minus 3. Well, my slope, there's an x. I can put a 1 in front of it. It's 1 over 1. Those are not the exact same, and they are not opposite and reciprocal, so those are neither. Okay, number 12. My current slope of y equals 4. Again, just y equals a number. My slope is 0. Bottom equation, same thing. Y equals -1. 0. Those are the exact same slope, so I have parallel lines. All right, last 3. Okay, top equation, y equals -1x. So my slope is -1 over 1. Bottom equation, y is not by itself, so we cannot identify our slope yet. We need to get y by itself. So I need to get rid of this -x and add x to both sides. Now I have y by itself. Now let's put these two terms in the correct order. We have our positive 1x first, and then -5. So now I can identify the term in front of my x and consider that my slope. So that is 1 over 1. So those are not the exact same slope, but one is positive and one is negative, and they are reciprocals of each other, so those are perpendicular. Okay, number 14, it looks like we're going to have to solve both of these equations, okay? So, to get y by itself, we need to get rid of that 1/4 x. Now, usually, when I've had a fraction, we multiply by the reciprocal, but again, that would only cancel out the fraction, and then we would still have the x. I want to get rid of the entire 1/4 x term. So it's a positive 1/4 x, so I'm going to subtract 1/4 x from both sides. So those cancel out. I have y by itself. And then again, we can't actually do the math here, so we're going to put it in the right form. -1/4 x plus 16. So that is my current slope, -1 over 4. Now let's go ahead and solve the bottom equation. To get y by itself, we need to get rid of that -8, so we're going to add 8. And I have 4x plus 8. So there is my slope. If I write it as a fraction, I get 4 over 1. All right, well, the one in red is negative, the one in blue is positive. And then if I flip 1 over 4, it becomes 4 over 1. So those are opposite and reciprocal of each other, so those are also perpendicular. And last one, number 15. We have x equals -8. Remember, if our equation starts with an x, our slope is undefined. And it looks like that's the same at the bottom. X equals 3, it's undefined. If I have an undefined and an undefined line, those are the exact same slopes, so those would be parallel. Okay, you guys now need to complete your exit ticket. When you have completed your exit ticket, get on your computer, go to your weekly planner, and check your answers. Once you have those correct, you may turn that in and grab your assignment, and you may work on that for the remaining part of class.